Hello, everyone, and welcome to today's Saratech Enablement session. My name is Rebecca Suchetz, and I'm a customer care representative here at Saratech, and I will be your host. Presenting today, we have Dan Nadeau, who is a Senior Applications Engineer, and he'll be talking to you about Introduction to Simcenter 3D.
Hey, thanks for the introduction. Hello and welcome. My name is Dan Nadeau, Application Engineer here for Saratech. Today I'm going to be talking about Simcenter 3D. Just want to give people a general information about the software and go through a couple demos and get everybody up to speed about the software. So here's just a picture of me in the top left corner, and in the bottom right corner is a picture of a disc golf course. It's actually in Massachusetts. It's one thing that I like to do when I'm out traveling and during my free time. So my expertise is in FEMAP, Simcenter 3D, Simcenter Nastran, and NXCAD. So the agenda today is I'm going to give you an introduction to the software, Simcenter 3D, and then I'm going to give you a brief overview of the software. Then I'm going to discuss the file structure. The reason why I want to discuss file structure is normally when I'm teaching or introducing new people to the software, this is where a lot of questions come. And once you understand how the software is, we'll say, organized, it makes it easier. And once you're used to it, it's actually pretty convenient. Then I'm going to go ahead and go through 2 demo models and go from the beginning to the end of those demo models. And hopefully that helps understand how the software is working. All right. So what is Simcenter? So Simcenter is a portfolio that consists of 1D, 3D, which we'll be discussing in detail today, and physical testing. So that's the portfolio as you see on the left. And inside the Simcenter portfolio is the software that we're going to be discussing as Simcenter 3D. Another software in this portfolio would be Simcenter FEMAP or Simcenter Nastran. So these are my words. So what is Simcenter 3D? So Simcenter 3D is a pre and post processor. So it is designed for the analyst. So it's not designed for a designer or a CAD user. It's designed for somebody who is doing FEA analysis as their primary task. So what it is pre and post processing. So pre-processing is all the entities that you would do before you send it to a solver. So create loads, boundary conditions, mesh, define your properties, materials, type of solution that you want to look at. Then you could send it to a solver. Now, one of the nice things about Simcenter 3D is it has the ability to use other solvers, including things like Nastran, Simcenter Nastran, MSC Nastran, Abacus, Ansys, LS-DYNA, etc. And it also has powerful post-processing tools as well. So this is going ahead and looking at the results after the model has been solved. So here's just a traditional CAE setup. So you grab your information, you import data, maybe you start with a CAD model, then you repair or edit the geometry, make it fit for the mesh that you want to have, apply your loads and boundary conditions, send it to the solver, and look at results. Now, with using Simcenter 3D, since it is built with the CAD in the background, so it's built within NXCAD, it makes some of these tasks very easy because you can use things like synchronous technology or use some of the powerful tools that are built into the CAD platform to go ahead and set up the model, especially repairing and editing geometry, just because you have all those CAD capabilities to help it. So helps with your initial iteration, and then all iterations after that fact are much easier to perform because it is, like I said, linked to that CAD and it's all integrated and it's easy to update. And I'll show you how we can do that in the demo model. One of the powerful things that we have here is, say we're working on this tractor in the image. You can have one model that works for all types of different solutions. So such as, acoustic, thermal, flow, structural, durability, fatigue, all with one single model. So that model can go and run any type of these solutions. And it, like I keep on mentioning, it's one common model. So you don't have to, when you go from structural to thermal, you don't have to remesh it. You already have the mesh model. You don't have to, continue to create new models. You already have the physical model. What I want to talk about today is, where I'm going to demonstrate, is using structural analysis. So in this case, I'm going to use Simcenter Nastran, and I'm just going to do simple linear calculations. but it has full capability to do nonlinear buckling and all other structural type solutions. So here's the basic file structure. This is for a single finite element model. There is a thing called assembly fem, and I'm not going to discuss that in this webinar, but it is another setup that you can do. So that would be if you had a full out assembly and you wanted to model that entire assembly as a finite element assembly. So what you have, and this is at the bottom of the FEA assembly, is the master part. So this is the part that is physically modeled inside a CAD. And then from there, you would create something called the idealized part. And we'll discuss further what an idealized part. And then you can also create your FEM part, which controls the mesh. And then you have your simulation part, which controls the solution and boundary conditions. Now, all these entities can be controlled or viewed in the simulation navigator. You'll see I have it set up here in the middle. And down here under the simulation file view, this is an option where when you are using the software, you're going to spend a lot of time, looking at the simulation file view to go back and forth between these individual FEA models, FEA, let's say, subparts. And they're listed here as the sim is the top level and the actual part is the bottom level of this assembly. When you are creating these parts, and we'll show this, you'll notice here it's showing you the FEM, the sim, and then you can create this idealized part. And we're going to dive deeper into why or what this idealized part is. So it's a specialized part inside the CAE realm. So why would you want to create it? You don't have write access to the master part. You're working in a concurrent engineering environment. So say I'm working with somebody else on the same part, and I bring in my local part that I want to do CAE analysis, and maybe I want to ignore a round, a fillet, a hole. I don't want to go ahead and delete that from the model and it affect his model. So I create my own local copy that's associative to his, but when I make changes, I do not update the master part. Now, I can have my localized copy update to the master part. If the designers, whoever's working on that part, makes a change, it will propagate automatically into my part. And I'll show that in a demonstration. It's also important if you're working in managed environments such as Teamcenter, so that if somebody opens up the master part, you can still open up your idealized part. And the important thing is here, you want to preserve the original geometry. So normally, if you look at your FEA world and you work on your part and you remove rounds and fillets and things like that, you're physically editing the geometry that you can't go back to where you started. Well, you could if you went backwards, but you're physically editing that geometry. Now, what this will do is it preserves your original geometry as well. So that stays put and you are only editing your local CAE type geometry. The next is the FEM part. So the FEM is where you have your nodes, your elements, your materials, your properties. And the sim part is where you have your loads, your constraints, and boundary conditions. So one thing that new users will run into issues is they'll be at the wrong level. So they're trying to, add boundary conditions and loads, but they're at the FEM level. So you just have to move on up to the sim part if you want to apply loads and constraints. But if you need to edit elements or properties, you have to do that at the FEM level, which is easy to do. As I mentioned earlier, using that simulation view, we can go ahead and move to the FEM or the sim or the I part or whichever is appropriate at that point in time. All right. So let's go ahead and hop over to Simcenter 3D and go through two demo models. I have two set up. One, I'm going to do a solid model. I'm just going to tap mesh it, apply some loads, some constraints, solve it, make some changes. And then we're going to look at creating a mid-plane representation of a part and go from there. All right. Okay, so I have a simple little bracket. I'm assuming that, maybe there's some bearings down here and then something's connected up at this top region, and I'm going to simulate it that fashion. So inside of NX, if you were doing NX, you're in your application, you're in modeling, and you'll notice that at the top, it'll say NX modeling or whichever application you are. And this is one of the powerful things with Simcenter 3D is you are in this NX modeling. So here's this master part that we could go ahead and we could use this to do additive manufacturing on this item, or we can do regular CAM. Maybe we want to mill this out of aluminum. Maybe we want to connect the other parts of this and run a motion model of it. We can do all that from the integrated environment. So I'm going to go, and if you select pre and post, this will bring you into Simcenter 3D right from NX. So you notice at the top it says pre and post, and now I am in the CAE world, if you will. To create the CAE items that I mentioned, we just select here on New FEM and Simulation, and we're going to go ahead and create our FEM, our Sim, and I'm going to create that idealized part right here. And this will take a second to load. And you'll notice in my simulation file view down here, when this is done, I'll create my solution. Just as we mentioned before, I have my Sim, my FEM, my I, and my TET. You'll notice right now, my work part right now is the FEM, and the Sim is the display. So in this case, I want to do a design change. So I'm going to go to my local idealized part. It says, hey, you must promote it so that I bring it to my local CAE level. So that's just a safeguard. So we'll just go ahead and promote this part. All right, so now any change that I make to this model will not affect the original model, but it will affect my CAE part. So I'm making localized changes, and I'm not going to mess with the master part. So in this case, I'm just going to do a little geometry idealization. I'm going to remove blends from the model, and some of these I want to keep for this simulation. Inside NX, if you hold down Shift, it's a deselect. It's going to remove a couple of these items. So the items in orange are going to be removed, and maybe I want to grab a couple more. I'm going to remove these little entities around the holes here. Looks like I misclicked. So hold down Shift to remove. There we go. Got it. And just walking through the model to go ahead and remove a couple of those entities. And now those blends have been removed, and I went ahead and set that up. If we went and looked at the model, I can just double click on this TET model down here, which is my master model. Those items still would be in that model. All right. So now I'm going into the FEM model where I'm going to apply my mesh and my materials and properties. Now, in my case, I'm going to do this merge face command because there's this split line between it. And this is just to help with my loading. And you'll notice when I get there. Okay. So now those have been merged, and now they just one smooth surface. What NX does, or Simcenter 3D does, is it uses this thing called mesh collector. So inside the mesh collector is where you define your element property and type. So this is going to be a 3D, and I'm going to make it out of a P solid, and I'll just call this aluminum. And I'm going to define my solid property, and this thing is going to be made out of aluminum, as I just mentioned. And I'm going to use, there we go, let's put this on the screen, aluminum 6061 for this case. So now I have a collector that's made out of aluminum. And now if I'm just going to do a simple 3D tetrahedral, we select the body to mesh, and then you have all these mesh properties that you want. And I like to hit my lightning bolt, give me an approximation. In my mind, I usually divide that by 2, and it'll give you a good element size. If you need to make any adjustments, there's full control over your mesh. There's also mesh controls if you want to, specify size on curves, edge, under, mesh control. Full FEA capabilities with the software. And it's going to be placed in that mesh collector down here. So now I have my object meshed. And if you want to, dig deeper, you can update your mesh or however you see fit. In my mind, I have 2 elements for thickness. So in my mind, this is okay for, my presentation today. If I needed to do more mesh control, I could go ahead and, use some of these commands as I would need. All right. So now I have my FEM model set up. It's meshed. I have my material, my property defined. Just going to double click on the sim, and now I'm at the sim level. And you'll notice that up here, my options have changed. So now I can define my loads and my constraints, where before I didn't have those options. I could only do mesh type options. So I'm going to constraint. I'm just going to assume that this bottom portion has been locked or seized. And then I'm just going to go ahead and apply a bearing load to this thing as if something was trying to pull this item out. So I'm going to grab load type bearing, and I'm going to select the inside face. And now it's asking for a vector, and I want to define it in this direction. But you'll notice that my coordinate system is not really in this direction, so you can use some of the tools inside here. So I'm just going to specify 2 points, and I can just say from one point to another point. I guess it's not correct, but I still have the vector going in that same direction. Okay, and now I'm going to go ahead and add a value. I'm going to say it's 300 pound force. All right, so now I have that load defined and it's displayed on the model. I'm going to go ahead and copy this load because I don't want to define it again. Right click on here. I'm sorry, up at this level. That's in the solution. I can just right click, clone it. There we go. Now I have a copy. And this one, I'm just going to deselect where it was defined before. And I'm going to select where I'd want it this time. Now, if I drag this into the solution, now you'll see it. Now, one thing that I noticed right now as I'm looking at it is I forgot to remove this little blend right here. So I can just go back to my idealized part. I can do the same feature that I did before, or I can double click on that command and I can go and remove it. I can use my synchronous technology to, delete this face. A couple different ways that I can go ahead and change that feature. All right, so back to my FEM. It's gonna yell at me right away. It's gonna say, hey, something happened to this mesh, and I don't know if it'll show up across the web, but it's showing me an outline. It's in black that, hey, something happened. Select the update, and it'll automatically update to match that new situation. All right. So if I fix my issue that I should have fixed at the beginning, but that's okay. But we showed that it's easy to make those changes. So now I have those loads applied to the model. I have my boundary condition down here. We went ahead and met our solution. Now, when I created the analysis, like a new FEM and SIM at the beginning, it gave me a basic solution 101 solution, which was fine. But if you need to create more solutions, you can just go ahead and select solution and define what solver that you're using. So if you have other solvers, you can specify it. And then what solution type. So in this case, I'm just going to do a solution 101. All right, so now I'm going to go and just right click solve, and you can also hit the solve up here. And let's look at some simple results. Now I know I'm going pretty fast. I just want to make sure I can cover 2 simple demo models. This will be recorded if you ever need to go back and review it as well. Now we also do at Saratech mentoring and teaching, if that would be something that you're interested in, setting up a class to go over some of the software as well. All right, so now I have my results, and maybe I'm interested in looking at something, I don't know, simple look at a displacement, and maybe I want to look at maybe von Mises stress. So I see my part, and it looks like, hey, I have some issues around here, and we can go ahead and make some observations of what it looks like. And in my mind, hey, let's go ahead and circle back and find a solution here. All right, we can animate it. You have full control over your post-processing. If you want to turn off your scale, you can edit your post view. You can change your display, your legend. You'll notice that the units are here as well. Now, one thing that I'm going to do is we saw some results. Let's go ahead and make some sort of design change. So let's go to our idealized part. And in my mind, let's make a simple design change. Let's go ahead and make this interior web a little thicker. Maybe it's getting a little bend to it. Select the face. There we go. And let's just pull it using just simple synchronous technology. Let's grab one face. I'm sure I could do both faces at once, but it's easy to do one at a time. So I'm just grabbing a face, pulling it out, 0.1 inches, make some change. Got an update. Looks like maybe this blend possibly could be a little bigger based on those results. Go ahead, grab that one. I guess I should grab both, but we'll do one at a time. That blend looked like it had a little bit of an issue. And now those changes have been made, simple changes to the model. We are at our FEM part. It's yelling at us again. I'm not sure if this is coming through, but it's showing me a new outline. We can update our mesh. Model's updated. We're at our sim level. I'm going to right click on my solution and hit clone. So I'm just going to create another solution. Now I'm going to solve it with these new changes, and we can compare, our original run to our modified run. This should take a second to solve. All right. So now let's look at our results, and let's start with, the von Mies stress. This is our original one. Now let's create two views at once. And in the second view, let's go and grab von Mies stress of our second case. And we can go ahead and link them together so that they'll move. All right. And just based on, the graph, you'll notice that we went from 3.6 KSI to 3.1 KSI. So if that was some sort of concern in our case, looks like we helped. And just thickening up this region right here, you notice that we alleviate some of this, high stress values. We can always turn on things like annotations. So you can see, well, that actually was on the edge. And now we can turn on the annotations, and now, this one's showing, hey, maybe we should have increased that fill it around over here a little bit, and it would have cut those down a little bit. So we can do simple design changes on the fly and look at them. And the important thing with all the items that I did, if I go back and we look at our original model, this thing has never changed. It still has those rounds, fillets, and things like that. So if this was used in somebody else's assembly or somewhere else in a model or integrated environment, their model would change the same. Now, one important thing is if somebody had this model and they made some sort of changes, it's going to make, see if this works. Some simple change, like this is, they realize, hey, this needs to be taller or something like that. If we went to our model, and this was at the global model, if we go back to our model, you'll notice that it's yelling at us and it's showing us that, hey, somebody made a change in that model. Would you like to update it? And then we can just hit update. Our model has been updated. If we like their change, we can take their change and then run our solution from there. All right, so let me just go ahead and close those entities, and I'll move on to my next demo model before I run out of time. All right, so here I have another fitting, and I want to go ahead and mid-surface this one. So just like before, application pre-post, create a new FEM and simulation. I would like to create my idealized part. And right here is where it asks me if I want to create a new solution. So in this case, I'm going to do a solution 101, and you can create the solution on the fly. All right. So in this model, we'll go to our idealized part. Let's promote it so we can make our edits. Do a simple thing, mid-surface by face pairs. Select our entity, select to mid-surface it. I'm going to hide my solid body, so I'm left with my midplanes, and it did a good job. Some of these things don't exactly connect 100%, but that's okay. We can use some of our tools. If you ever had any issues, you could go over application modeling, and you have full, you can use your surface modeling or everything else that's inside of NX to go ahead and clean this up. But since this is a simple extend, we can do an extend sheet, select what we want to extend, and then where we want it to go, and we can complete this command for the rest of the structure. Go to there. There we go. So got our model set up. Go to the FEM. Now, if you are doing any sheet metal, or thin-walled structure type parts, highly recommend using the stitch edge command. And this will combine the edges together so that you don't have to, they will create manifold edges between it. So you don't always have to do this check for duplicate nodes. They should be merged because they share that common edge. Now, any command that you're doing, you can just select, maybe any command. If you press the F1 key, it will open in context help. All right. So anytime that you're in trouble, F1 for most Siemens products will bring you to in context help on that subject. All right. So I'm going to throw a 2D mesh on this one. Select the object I'd like to mesh. Use my lightning bolt to give me an approximation. I divide it by 2. And this time I'm going to say automatic creation of the collector. So it went into a collector called thin shell. Now, inside here is where our materials and properties are defined. We never define any materials and properties, so we have to make sure that you edit and you give it a thickness. In this case, we're not going to give it a thickness. I'll show a trick. Grab my material, 6061 aluminum, and now it is based on aluminum, and it has a thickness that is related. If you right-click on your mesh, you can say Edit Mesh Associative Data, and this thickness doesn't come from the physical property table. It comes from the mid-surface that we created inside of NX, and it's going to give me a thickness evaluation at every node. So if I right-click here and I say Plot Thickness and Contours, it's going to plot those thicknesses for me automatically. So I didn't have to define all those individual properties. It just knows from the mid-surface creation what these are. So if I went ahead and updated the geometry, it will automatically update the thicknesses here. So now I have my materials, my properties. We'll go to the sim model, apply our loads and constraints. So fix, just going to do a simple fixed constraint. I'm just going to do polygon edge. Using some of these NX filters will make some of these selections much easier. So now it's fixed. Maybe I want to do a connection between all these. I want to create an RBE2. I can do that at the FEM level because it's not a load type entity, it's an element. So you have to move back and forth between these entities to make sure you're at the right level. It's going to create a point in the middle of all these. Let's say between 2 points and this circle, this circle. There we go, got a point. And now let's do a 1D connection, point to edge. So point, this point, edge is these guys. And now I created an RBE2 that connects all these together, as if all these were linked together. It's easier for me to do one load. Maybe I want to do some dynamic loading into this. To me, this is the easier way to do that. If I want to change, any of the display, I can change that very easily to make it stand out as well. All right. So I have my loading almost set up. I'm going to apply a load to the center node, just so it acts on each one of these as one entity. Load type, just going to do a force. I'm going to make sure I apply it to this object, not that object. Change our filter to node. There we go. And I'm just going to do 200-pound force. And the vector, I turn on my geometry, and now I can use my vector like that. So the item is acting along that plane. And now I have my model set up. I can go ahead and solve it. So hopefully I'm showing that it's pretty easy to go ahead and set up models, do mid-plane representations as well. The powerful features inside of NX, if you ever have any issues, you can leverage the CAD capabilities as well. So looking at post-processing, you specify what vector you want to look at, and then you have full control. So maybe I'm looking at stress, and I notice that, hey, maybe the stress is here. Right now, I'm looking at unaveraged results, but if I want to, look at maximum results, you'll notice that my chart's going to update, and I can make any sort of, post-processing information. If I want to, investigate some results, hey, just, plot them out. I can grab them. I can send those right to Excel directly from here. So I just identified which ones I want, hit this Excel, it's calculating, it's on my other screen. And there I go. I have the location, the node, the location, and its von Mises stress. Looks like I'm running out of time. So let's do one quick thing and then I will wrap it up. So what I mentioned earlier is that if somebody would make a change to the model, so maybe it came back that, hey, this space in the bottom here was not beneficial. Let's go ahead and replace this face with this face, and now it's just a flat bottom. So hey, that little cutout was causing issues in manufacturing or wherever. We can go ahead and make that change. So that was at the local, the top level model. And you'll notice that, we might need to make some changes and update our model. So it went ahead and it updated. It's got the new change. I can right click, plot thickness and contours. And now you'll notice that the entire base is updated to that new thickness based on this scale over here. And if we wanted to, we could go ahead and solve it. I'm going to clone the solution just so I don't delete my old results. Right click, solve, and get some results. And it only takes a second if you do mid-surface models. Nope. And just as I showed before, do a quick comparison of our first solution, von Mises stress, to our second solution, von Mises stress over here. Looks like I forgot to include a results. A load or a constraint. So I guess with my little mishap, just trying to make sure I got something in before I ended, I forgot to include my my load or my constraint in that case due to an update. We'll just stop it at there and finish up here. All right, so hopefully my notable takeaways here was I showed you what Simcenter 3D is and some of the features to it. There is tutorials out there. If you are using the software, this is in the help documents. There is a link to get to the tutorials based on their help documents. I gave a nice overview of the product. I showed you how the file structure works, and then I gave you a quick demonstration of the product. Sorry, I ran out of time. I wanted to do a little bit more, but based on time, we had to finish it up. So thank you for your time. I appreciate it.
Thank you, Dan. And like Dan had mentioned earlier, Saratech offers much more than software. We also have a wide variety of options for training, services, and 3D printers as well. So if you have any questions about that, you can email us at marketing@saratech.com. And please be sure to subscribe to our channel. You can also follow us on Twitter and LinkedIn for any upcoming webinar dates and topics. So thanks guys so much for attending. Thank you again, Dan, and hope you all have a great rest of your day.
Thanks for checking out our channel. If you like what you saw, make sure to like and subscribe down below so you don't miss out on any new videos. Follow us on LinkedIn, Facebook, and Twitter for the latest engineering news and information. And to see all of our upcoming events, please visit our website at saratech.com/events.